Hello, my dear students. Very good afternoon. How you all are doing? Hope you had a great start with the college today. Anyways, you all stay safe. Go to the college in a proper, disciplined manner. Okay. So I suggest it's always better you keep a distance. Okay. So go ahead with all the precautionary measures. Okay, so I hope you all are carrying sanitizer and all those things that are required, I suppose. So here today we will be beginning our discussion with units and dimensions. Okay, this is a 11th standard chapter that we all know already, and in this particular chapter, my dear students, we will be focusing on important problems on units and dimensions. Okay, and in today's session, I will be focusing on some of the foundation things related to the problems. Okay, for next half an hour. In the next session, that is tomorrow, I'll be covering some quality problems on units and dimensions which have previously appeared in the entrance exams. Okay, so without much ado, let's begin our discussion with Unacademy's YouTube live session on units and dimensions, my dear friends. And you all know me as Uttam Kumar Umarji. I'm an MTech graduate. In fact, I am your personal physics teacher. I'm having 19 years of experience, and presently I'm enjoying number two position as an educator in Karnataka CET. And in order to unlock your plus subscription, always go ahead and use Uttam Live as your unlock code. Okay, so Uttam Live is my plus subscription unlock code, so you can go ahead and use this. Okay, so this is the referral code, my dear students. Fine. Now talking about the next part, my dear friends, that is my experience. Okay, so in fact, in these long 19 years, I have worked at various institutions all across India. I've worked even at Kota, Delhi, as well as in Bangalore, and in various other places like Salem, Coimbatore. Okay, I have worked all across the country, and I've taught diversified number of students all across the country, and even I have taught to the children from rural background in their rural premises as well. Okay, so I know the dearth of quality education is very much in need nowadays. So, with reference to this, my dear friends, I began my quest of finding better quality students to provide better quality to the students. I went ahead with Unacademy platform, and this Unacademy platform happens to be one of the golden gate for my students. I know that because within one click of a icon, you are entering into the knowledge world. That's it, right? So briefly, I as I was mentioning to you, I've taught J Advance and JEE Main Physics for 19 years. Okay, all across India, and then taught to closely 10,000 plus students till date as of now. Okay, and third month over now. Okay, so I'm actually entering into fourth month here. So here I've finished 3 months on an academy. That is the advantage here. And secondly, I'm not new to teaching, but I'm new to an academy platform. That's all. Okay. So how you all are doing, my dear students? I would like to see your messages here. I would like to see saying, wishing me. Okay, so that the energy keeps on. Uh, rising up, is it not? Fine. So now talking about Unacademy, my dear students. Now let me just give a brief intro about Unacademy. What offers Unacademy can provide to you. Unacademy Plus subscription is one of the highly uh, intuitive thing that any student can go ahead and grab this opportunity as. Okay, now over here, remember Unacademy Plus subscription, we have some of the best plans laid out for Karnataka CET 2021. Okay, and I know most of you are KCET aspirants. So with reference to this, I can say that you have a 12-month plan up ahead. Okay, which would cost you 12,375 rupees per month for 12 months. Okay, and you have an easy monthly installment facility, EMI facility for 1,031 rupees per month. Okay, so secondly, we have a 6-month plan which is up ahead with 10,125 rupees, which would cost you around 1,688 if you are paying monthly EMI. Then you have a trial price, a 1-month plan, which would cost you 2,250 rupee. This is only for the new subscriber. Okay, so please remember this. Then what it can offer you? Obviously, the content would be top class. Okay, and the live courses are highly structured, my dear students. In fact, you are seeing YouTube live session now. Look at the quality of video that you are getting. Now this is where like Unacademy promises to you. And then we have a dedicated live doubt clarification sessions which are obviously conducted after every 2 or 3 sessions. So imagine how your doubts will be clarified, how you will be like improving your knowledge. So that is most important, right? Then quizzes are at regular intervals for self analysis. Okay, then we have batches for complete preparation. Hmm? Then test series for containing daily practice papers. Okay, and then full length mocks. These are too important for us. With analysis you will be getting, and all in all I can say one single subscription can provide you unlimited access, is it not? Okay, so with the note of this, I haven't seen your messages here, so can you please message saying hi, good afternoon, because I want to get energized before I proceed with the session, my dear friends. Yes, here show that you are here. So we can say that a comprehensive batch is presently a live batch is running, and this live batch, if you want to enter, my dear students, and in that batch I would be teaching physics for you. Okay, and this month you will see a lot many classes from my side with quality notes. Okay, in that particular plus batch, so kindly go ahead and grab this opportunity. And in order to avail a 10% discount, my dear students, while you are subscribing, I suggest you go with this particular code UTTAMLIVE or UTTAM2021. Okay, so this is my code for YouTube live classes, Uttam Live. So here you will be offered a straightforward 10% discount here. Okay, so this is the advantage that I can give it to you. This is your teacher's gift, my dear friends. Now talking about like, let me just, as I was mentioning it to you, we will take a look at some of the intermittent basic concepts today. Okay, so today we will be focusing on some of the basic things like formulations. Okay, so that if we understand those modalities, we can very easily solve the problem. So in my tomorrow's session I'll take a look at problems, but today we will focus majorly on important terminologies. Okay, so first and foremost thing, let me define dimensions. Okay, so you can say dimensions of a physical quantity are the powers to which fundamental units in length, mass and time are to be raised in order to equate the physical quantity. Is it not? So here this is what you all can remember from your first PUC basic or class 11 basic. Is it not? So here comfortably we can define a dimension like this. Suppose I can write a dimension of some physical quantity, say P, some physical quantity P. I will write it like this. Dimension of physical quantity P is equal to, okay, m raised to x, then L raised to y, then T raised to z, T raised to z, and we have so many other fundamental physical quantities. Even we can go ahead and make use of them. For example, suppose I have temperature. A temperature I'll consider like this: theta raised to a. Okay, temperature is theta here. Theta raised to a, or amount of substance, mole. So I can write this as mol raised to b. Okay, then you have one more fundamental physical quantity. Like there are 7, right? So we have written how many? 5 right now. We have electric current. So for electric current, a is the symbol that we use. Okay, capital A raised to c. This is for electric current. Okay, then we have luminous intensity. So suppose you are mentioning luminous intensity as one of the fundamental quantity in that physical quantity, then luminous intensity raised to d. Okay, likewise we write a dimensional equation in this pattern. So I hope it is clear to you. So this is how we progress with dimensional equations. Is it clear, my dear students? Okay, so now let's talk about deriving the dimensions of some physical quantities. That would be our basic concept building in this particular session now. So firstly, I'll consider dimensions of velocity or speed. Okay, so velocity or speed, we can write it as what? Distance by time, because velocity is displacement per unit time, but magnitude of displacement is distance, right? So hence we can also write it as velocity has dimension of distance in the numerator and time in the denominator. So obviously I can write this as dimensions of velocity V is equal to L by T. Distance has fundamental physical quantity of called length, then time is obviously capital T. So I can write LT raised to minus 1. So this is velocity or speed. Now secondly, acceleration, if I consider, obviously acceleration is defined as what? Velocity divided by time. Okay, and hence I can comfortably write dimensions of acceleration is equal to dimension of velocity divided by time. Okay, so dimension of velocity, here only we have written it just now. So it is LT raised to minus 1 divided by T. So that should give me LT raised to minus 2. Is it not? So these are the dimensions associated with acceleration. Now talking about linear momentum. Now linear momentum is defined as what? Mass into velocity. Linear momentum is product of mass and velocity. So hence I'll write this as, its symbol is small p. So p has a dimension of mass capital M, then velocity is LT raised to minus 1. So therefore p is equal to MLT raised to minus 1. So these are the dimensions that we have right now. Okay. Then talking about force. Force is mass into acceleration. Okay. So hence over here I can comfortably write this as what? F is equal to m into LT raised to minus 2. So I'll get this as MLT raised to minus 2. Okay. Then impulse, if I consider, it is force multiplied by time. So force has a dimension of what? MLT raised to minus 2 and time capital T. So we'll get this as MLT raised to minus 1. So here you should remember that linear momentum and impulse, they have same dimensions. Okay, their dimensions are same here. Fine. Then to derive the dimensions of work, energy and power. So over here we should remember that work is nothing but force into distance. So obviously force has dimension of mlt raised to minus 2, distance has dimension of length capital L. So hence I can write this as mlt raised to minus 2 into L. So that would give me what? ml square t raised to minus 2. Okay. Then power is work done per unit time. So obviously here work has dimension of what? ml square t raised to minus 2. We have just now derived it. Okay. So hence I can write ml square t raised to minus 2 by t. That should give me ml square t raised to minus 3 here. Okay. So thus I can comfortably understand regarding work and power. Okay. Remember, work or energy, both of them have this particular dimension, and this is the dimension of power. Okay. Fine. Now talking about moment of inertia after this. Okay. So moment of inertia is nothing but the product of mass and square of the distance from the axis of rotation. Okay. So suppose I consider some axis about which a particle is revolving like this. Okay. This is r, radius is r here, and suppose the mass that is attached here, or mass which is revolving like this, is small m. Then moment of inertia is nothing but product of mass into perpendicular distance from the axis of rotation. Now this is the axis. This is the axis of rotation that we should remember here. This is axis of rotation. So accordingly we'll obtain it like this. Okay. So hence we can comfortably write this as what? I is equal to mass into radius of gyration. We can also call this as radius of gyration. Okay. This is not gravitation. This is radius of gyration, my dear students. It is gyration. GYRATION, radius of gyration square. So this distance perpendicular, this distance from the axis of rotation, this is the radius of gyration, my dear students. Okay. So its square we can consider. So accordingly I can write this as I is equal to m into r square. So then dimensions are very simply written as what? Capital M into L square. That's all. Next we should talk about angle, plane angle. Okay. Now plane angle is arc length by radius. So hence over here we can write this as L by L. Arc length is length only, right? Length of an arc is length. Then radius again has dimension of length. So obviously we'll get this as what? L raised to 0 here. Then hence we can say some physical quantities, they have no dimensions. They are called dimensionless quantities. So you please remember this point, my dear friends. Okay. Like we can take example like angle, strain, refractive index. Okay. Coefficient of I can say friction, coefficient of friction. Okay. Even that is dimensionless. So likewise there are so many physical quantities which do not possess dimension. Okay. Then we should talk about angular velocity quickly now. Angular velocity omega is ratio of angle covered divided by time it is. Okay. So we know that angle does not have any dimension, is it not? So hence dimension of theta is what? M0 L raised to 0 T raised to 0, which is 1 here, and dimension of time is capital T. So hence its dimensional equation is T raised to minus 1. Then angular acceleration is ratio of angular velocity and time. So accordingly I can write this as alpha is equal to omega by t. Okay. and omega's dimension is what? T raised to minus 1. So we'll substitute it here. So accordingly we'll get this as T raised to minus 1 by T, which should give me T raised to minus 2. Okay. Then angular momentum after this. Now angular momentum is moment of inertia multiplied by angular velocity. Okay. So I into omega we write it as. So moment of inertia has dimension of m into r square, moment of inertia, and omega as it is I am writing. So accordingly I can see that I'll write m L square T raised to minus 1, right? So we'll get the dimension as ml square T raised to minus 1 here. Okay. Then talking about torque. Now torque is moment of inertia multiplied by angular acceleration. We can write it like this. So hence we can write mr square into alpha. So accordingly I can write this as ml square T raised to minus 2 here. Okay. Now, if you just observe here, torque has same dimension as that of work. Okay, so work and torque, both of them are same dimensions, but physically they are different. Remember that. Huh? So work, energy and torque, they possess same dimensions. Okay, so that is what I have mentioned here. I hope it is clear. Now pressure and stress, next step. So pressure, if you just talk about pressure, pressure is force upon area, and stress is also force upon area, but only difference is like in case of pressure we will consider normal area, in case of stress we will consider either of normal area or parallel area or tangential area. So obviously formula wise they are same, so that is why they must have same dimension that we can understand as. So hence ml T raised to minus 2 is force divided by L square is ml raised to minus 1 T raised to minus 2. Okay, so these are the dimensions of pressure and stress. Okay, then talking about next one, that is longitudinal strain, my dear friends. Now longitudinal strain is increase in length by original length. So increase in length by original length if I write. Similarly we can say bulk strain. Next step, it is increase in volume by original volume, that is volumetric strain we call it as. Okay, then over here strain, hence we can say that its numerator and denominator are either volume or length here, length by length or volume by volume here. So obviously it is a dimensionless quantity, it does not have any dimensions. Then Young's modulus, next one. Young's modulus is stress upon strain. This is from Hooke's law. We can understand that Young's modulus is the ratio of stress and stress to strain. So therefore I can write strain is dimensionless quantity. So hence Young's modulus and stress have same dimensions of pressure, right? So pressure and stress, they have same dimensions. So thus I can say Young's modulus equal to ml raised to minus 1 T raised to minus 2. We have already made that derivation if it is clear to you. Okay, then we should talk about energy density. Okay, so energy density is energy per unit volume. Okay, so hence dimension of energy divided by dimension of volume we write. So dimension of energy is what? ml square T raised to minus 2, and volume has L cube dimensions. Okay, cube of length volume, is it not? So hence we can say energy density equal to m L raised to minus 1 T raised to minus 2. And remember this dimensional equation what we have obtained, no, this is also hysteresis area of hysteresis graph. Hysteresis area, this also you should remember, my dear friends. Okay, so in case of magnetic properties, in case of elastomers, okay, we will get hysteresis. okay, that hysteresis area under hysteresis graph is energy per unit volume. Remember this. Next, we should talk about linear density and volume density of mass. Okay, so linear density of mass, that is mass per unit length it is. Okay, so mass per unit length is mass by length that we have. Then we can write ml raised to minus 1 here, is it not? Then volume density of mass, that is mass per unit volume it is. So we can write mass by volume, that is d is equal to, dimension of d is equal to ml raised to minus 3. Then talking about surface tension after this. Okay, now surface tension happens to be force per unit length. So hence we can write dimension of surface tension equal to dimension of force divided by dimension of length. So accordingly, force has dimension of what? mlt raised to minus 2, and length is capital L. So clearly we can see L and L can be cancelled here. So thus we'll obtain it as what? mt raised to minus 2. Then let's talk about velocity gradient after this. Okay, now velocity gradient, it is velocity per unit length, that is velocity gradient. Okay, and it is usually denoted as dv by dx, and this velocity gradient is predominantly used in Newton's law of flow of liquid. Okay, in case of flowing liquid, laminar flow of liquid, we use a law called as Newton's law. Okay, in that Newton's law, velocity gradient based derivation is made. Okay, then over here velocity gradient dimension, hence it can be written as dimension of velocity upon dimension of length. So dimension of velocity is what? lt raised to minus 1 and divided by dx, that is length here. So hence we can comfortably see that we'll get the dimension as t raised to minus 1, is it not? Then 22nd, we can go ahead with coefficient of viscosity after this. Okay, and to find coefficient of viscosity, I'll make use of Newton's law of viscosity. Now this is Newton's law of viscosity. According to Newton's law of viscosity, the viscous force, or the force of viscosity between two layers of a liquid, is found to be equal to eta into A into dv by dx. Okay, so from this particular equation, I can very easily derive the value of eta. Eta is coefficient of viscosity here. So accordingly, I can write this as eta is equal to f by dimension of area into dimension of dv by dx. Now dimension of dv by dx is t raised to minus 1. Okay, dimension of area is what? L square. F dimension is mlt raised to minus 2. We have already seen that. So accordingly, I can substitute these all values and see that I'll get the equation, dimensional equation, as m L raised to minus 1 t raised to minus 1. Okay, now these are the dimensions associated with coefficient of viscosity, my dear friends. Okay, then now we should talk about Planck's constant quickly. Now, Planck's constant happens to be one of the constant value which we get in case of Einstein's equation and Planck's theory. Okay, so according to Planck's theory, energy associated with a photon is given by E is equal to h into nu. Nu is frequency here. Okay, frequency of that particular photon, and h is called as Planck's constant. Okay, so from this I can very easily say that therefore h is equal to E divided by nu. E by nu, where nu is what? Frequency, my dear friends. Okay, so h is Planck's constant, nu is frequency. So from this particular equation, I can derive dimension of h here, right? So hence I'll go with E is equal to h nu. Therefore h is equal to E by nu, and I can write this as E into 1 by nu. Okay, and accordingly I can write this as E by nu is ml square t raised to minus 2, that is energy. Dimension of energy is ml square t raised to minus 2. Then frequency dimensions are what? T raised to minus 1. Is it not? So I'm just mentioning that. So accordingly we tend to get the value as ml square t raised to minus 1 here. Okay, so these are the dimensions associated with Planck's constant, my dear friends. So I hope and students, I have tried to give you some of the foundations on dimensional analysis, and in my next session, that is on tomorrow, I'll come with some standard problems on units and dimensions. Okay, so please do tune into my next YouTube session. Okay, so please go ahead and uh, complete your feedback, submit your feedback, like my video. Okay, and I hope you have enjoyed learning all these things on Unacademy's YouTube platform. And let me remind you, whatever we learn in a day, that lesson we should always complete on that day itself. So that should be the target we should go ahead and keep. Okay, so hence with this note, my dear students, I'm just trying to sign off. So I'll see you back in the next session, that is on 2nd of January, time 3 p.m. to 3:30 p.m. So please do tune in to this particular session. So I'll see you by tomorrow. Then have a wonderful time. Have a beautiful new year first day ahead. Okay, then I'll see you back in my special class session as well as in my plus classes. Okay, thank you. Have a wonderful time. Bye.